Okay, so we're going to get started with the live stream. And this is our last live stream of the year. So we're going to cover our last topic, which is substituting to solve equations. So we're just adding the element of needing to do some substitution before we actually get to the equations and solving them. We've worked with substitution in the past. You know, we've substituted things like length and width into a formula to find the area. And so we're working in the same nature, except instead of finding the area, perhaps we're finding the width or the length. And so we'll need to do some of the rearranging and solving for that missing variable. So the questions that were assigned with this section were 1, 2, 4, 7, and 9. So we're going to take a look at, I think we have time to take a look at all of them. They're fairly concise questions in this section. Again, if you have questions along the way, feel free to send a message in the chat, send a message via email or EDSB. After the video, I can still take some questions if you send me messages on EDSB or via email. I'm not sure how long the class will be available to you on EDSB. If it stays for the summer or not, but I am always available via email. You can always send me an email if you need to get a hold of me throughout the summer. The videos will all be up too, so you can always check those out. If you didn't get a chance to get through all the content, those are a great way to make sure you're staying up with the materials and getting yourselves ready as you move on into grade 10 mathematics. Anyways, to get started, we're going to take a look at question number 1. And that question is a perimeter type question. So we're given the formula for a perimeter of a rectangle being P equals 2L plus 2W. And then we are given that the length of that rectangle is 19 and the perimeter is 63. So we want to find out how wide the rectangle is. So I've already set this one up here. There's our perimeter of 68. There's our length of 19. What we do to start this, we just fill in the formula with those values. So P equals 68, 2 times the 19, which is our L, plus 2 times the W. Now in this case here, we have 2 times 19. We can actually calculate that now and get rid of that multiplication. That'll just clean up this equation, make it a little simpler for us to work with. So 2 times 19 is going to give us 38, and then our plus 2w. So now we have 68 equals 38 plus 2w. This is very similar to what we were doing in the last section. Now we're solving for w, so we got to look at what process we would use to calculate w and then do everything reverse to solve for w. So if I was using BEDMAS here, I'm going to do 2 times w and then add this 38. So we're going to do that in reverse. We're going to get rid of the 38 first, then we can get rid of the times 2. So we're adding 38 here. So the opposite of adding 38 is subtracting 38. So we're going to subtract 38 from both sides. So 68 minus 38 equals 38 plus 2w. And then we're going to subtract our 38 from that side as well. So we've subtracted 38 from both sides. That clears it out of there. And then there. And now we have 68 minus 38, which is going to give us 30 equals 2w. And now to get rid of the 2w, we divide by 2. It's 2 times w. The opposite of multiplying is dividing. So we divide both sides by 2. And we're going to end up with 15 equals w. And there is our width. So again, good idea when you're doing these types of questions. Write out your variables on the side. Oftentimes in science classes we'll get this, especially in physics. It helps us determine which formula to use. In this case, we're given the formula, but we wrote our information and our formula, filled in what we knew, and then simplified where we could. And after that, it was just using the opposite process that you'd use to BEDMAS to remove all the items, do the opposite operations, and work our way down to the 15w equals w. So moving on to the next question, we are looking at a catering business that's run by a gentleman named Kyle, who's charging $25 for a cheese platter and $35 for a dessert platter. One of his orders costs a total of $335, including 6 dessert platters. We're going to use the equation T equals 25C plus 35D to determine the number of cheese platters in the order. So looking at that equation, 25C, that's $25 times the number of cheese platters, and 35D would be $35 times the number of dessert platters. And so we're just going to fill in our values and then work around to solve this equation. So again, I've set this one up here. We had 6 dessert platters, total cost of $335. Fill in our values into the equation. 335 equals 25C. We don't have the number of cheese platters, that's what we're trying to find. And then plus 35 times 6. And again, like the previous question, this is very similar in that we can simplify this 35 times 6, and then we can go about solving for the C. So 335 equals 25C plus, and in this case, 35 times 6 is 210. So now, looking at this, we would first, to solve it, or to calculate it, we would multiply 25 by C and then add the 210. So we're going to remove everything using the opposite process. So to get rid, we're going to get rid of the 210 first, and then we're going to get rid of the 25. So we're adding 210 to get rid of that addition of 210. We're going to subtract 210. So 335 minus 210 on this side, and then 210 minus 210 on this side. And again, we're doing it to both sides because we've got to keep it equal. So whatever you do to one side, you have to do the same thing to the other to keep the equation equal and balanced. So on this side here, those two 10s are going to cancel, and we're just going to be left with 25C. And then we have 335 minus 210, which is going to give us 125. So now we have 125 equals 25 times C. The opposite of multiplying by 25 is going to be to divide by the 25. So we're going to do that on both sides. And that will allow us to get rid of the 25s here. We're just going to be left with C. And then 125 divided by 25 is going to leave us with 5. Thus, 5 cheese platters were part of that order. Now, these first two questions, we were given the equations. In the case of the first one, we're familiar with the perimeter formula, and we can look it up as well. In the second one, it was an equation created for that specific situation. And so as we move on to the next question, which is question number 4, it's one that we're going to actually have to create the equation ourselves. So here we have Christian earns $10.55 per hour working as a waiter. Each week he earns an average of $200 in tips, and given that his last paycheck was $516.50, how many hours did he work that week? So here we are making the assumption that he is including his tip as part of his paycheck. Sometimes you just put those tips in your pocket. Sometimes they actually are going to the business, and then it gets redistributed to the staff, which I'm assuming is what's happening here. So he's got an average of $200 in tips, $10.50 an hour, or $10.55 an hour, sorry, and he's making $516. How many hours did he work? So got that information there, and we need to make an equation that relates all this information together. So thinking about hours worked and money made and the tips, he's making a total. So how much does he make? A total, we'll say, is his total pay. In this case, his total pay, well, he's going to get his $200 in tips on average each week as part of his pay, plus he's getting $10.55 an hour. So $10.55 an hour, we can multiply 10.55 by h. So our total is 200 plus the $10.55, and we could even write this as an hour. So it's 10 if we kind of write it out with the words, and then we can simplify that into an equation. We can just use t for total. So the total he makes is 200 plus 1055, and that's each hour. So every hour he's making that, so we're going to multiply that by h. So there's our equation. Now we can fill in our values. He's making $516 in this week here. We got 200 as tips again on average, and then 10.55 per hour. And so now we go about solving this. 10.55 times h would be where we would start to calculate it, and then we'd add the 200. If we were using BEDMAS, so to do everything in the opposite order, we're going to divide by 10.55, then subtract the 200. Or sorry, we're going to subtract the 200, then divide by the 10.55. So we have $516.50 minus 200, and then we're going to subtract 200 from this side as well. So subtracting it from both sides, these will cancel, and then we have $516.50 minus 200. That's going to give us $316.50. So that equals 10.55 h. 10.55 times h, opposite of times is divide. So we're going to divide 10.55 out on both sides. 10.55. And when we do that, these will cancel, giving us our h, and we got $316.50 divided by 10.55. That's going to give us 30 hours. So this week he worked 30 hours. So again, this time we had to create our own equation, and in the next couple questions, we're going to be working with similar ideas. Explicitly in number 7, number 9, we won't have to quite have the same, because we're going to be given some area and perimeter, but we've created our own equations. So we created our equation using the information given, subbed in our values, and then we're able to calculate. Now, in the next question, which is number 7, we have a cell phone plan that costs $99 for a phone, and then an additional $25 a month for unlimited talk and text. So he's paying $99 up. Whoever is getting this is paying $99 up front for the phone, and then each month we'll pay $25 to get unlimited talk and text. We want to write an equation using the letter M to represent the number of months it will take to reach a total cost of $74. So this is a cumulative cost. So initially he'll pay the $99 and the $25 a month, and then each month he's going to pay that additional $25. So this is one of our partial variation questions, or equations, sorry, that we're going to make. So we'll take our information and create an equation here. So our phone was $99, monthly it was $25. We're looking for that total to be $374. So starting with our total cost, that's going to equal the initial cost of the phone plus the $25 per month. And again, this would be our K value. This would be our B value in our partial variation equations from the linear systems section. So now we can fill in our total cost here, which is we're looking for when it reaches $374, and we're going to solve for M. And now, again, like the last couple questions, we're going to get rid of the addition first and then the multiplication. So we're going to subtract 99, that's a 4, minus 99. So we're going to subtract that 99 from both sides, and that is going to get us down to 25M on this side. And we're going to get 275 on the other side. And now we're just going to divide by 25. So those will cancel out each other, get m. And when I say cancel out, they don't actually cancel out. 25 divided by 25 is 1. We're left with 1m, or just m in there. But we can just kind of scratch them off too, because they're opposites and remove each other. The next part there, 275 divided by 25 is going to give us the 11 months that it takes to reach the $374 cost. So that there is our solution. So very similar to the previous question in setup and everything. Now, in the last question, we're going to be working with a couple of equations that we're familiar with. So we have a square tile that has a perimeter of 16 centimeters and an area of 16 centimeters squared. So we want to write an equation to represent the perimeter of the square tile. Then we want to solve that equation. Then we want to determine how we can verify that our answer is correct. So we got a 16 perimeter, 16 for area, and this is the special case with perimeter and area of a square where they are the same, but we want to write an equation to represent the perimeter of this square tile. So perimeter equals 2L plus 2W. Now, we know the perimeter is 16. So we can sub that in. Now, the other value we're given is area, but area doesn't fit into this formula explicitly. So when we go to solve it in the next step, which is B, we can't solve anything. We don't have any values to solve this equation yet. But what if we think about the shape? Length and width of a square are the same size. So the length equals the width. So here we got to use some of our knowledge of a square to recognize that the length equals the width. So we're going to substitute in W for the L. So instead of L, I'm going to replace it with W, and then we still have the plus 2W. So now I have 16 equals 4 W's, because 2W plus 2 W's is a total of 4 W's. 16 equals 4 W. Now we can solve this. We can solve this equation for the width, and that's part B. We're just going to divide both sides by 4. Those 4's will cancel. 16 divided by 4 is 4. So our side length on this square is 4. And now part C had asked, how can we verify that our answer is correct? Well, this is where our area comes in, because area is length times width. So if we substitute that into the area formula, area equals length times width, and because the length and width are both 4 in the square, we'll substitute in our area value we know, and then we know the length and width are 4. And we just have to see if that's true. Is 4 times 4 16? And yes, 4 times 4 is 16. So we get 16 is 16, and that's a true statement, thus it is correct. If we got something other than 16, it wouldn't be true. 16 is only equal to 16 and not equal to, say, 17 or 20 or 72. So
this here tells us that we have a true statement. That's one way to verify it. Given that we know the area, we can check simply by substituting that value in to our area formula. And that shows that we did the work correct the rest of the way. So in this case, and there's another way we could have done this. Some might recognize that the perimeter of a square is just 4 times the side length, but I felt it was important to show you guys the method where we use, because generally we just throw out the length times or 2L plus 2W formula for perimeter, even if a square, because a square is a special rectangle. But it's good to show you guys this idea of substituting that W in for the L. So we replace, even when we substitute numbers, even though we're always usually substituting numbers, right? We can also substitute letters in for letters if it makes the equation simpler, like it did. It just gave us one variable, W, and allowed us to solve it. And that's going to be useful next year when you are solving what are called systems of equations in grade 10 math. So that's the last of all the questions that we have. That's everything from today, this section. Again, if you are still working on some of this stuff, trying to get through it, make sure you're ready for next year. Feel free to send me messages. You can message me on Edsby, and you should have access to Edsby even if you don't have access to the specific course. You can just type my name in, and you can send me a message. Or you can send me an email through the school email, and I can answer any questions for you. Beyond that, I'm going to say if you want to know your percentage grade, if you haven't seen that on Edsby yet, you can send me a message and I'll send you your percentage grade. Otherwise, have a good summer and take care.